Hi, everyone, and welcome to the series of webinars by Be My App. We'll be starting in 2 short minutes. We'll be starting again in 2 short minutes. See you soon. Just FYI, guys, you can actually, if you have any questions, you can type them in the comment section on the YouTube channel, or if you see the little pop-up over the video, it says be part of the conversation. If you click on that, it would actually open up a questions tab, so you can go along with the video and ask questions a long time. So with that, I just want to say thank you all for coming down. Again, this will be an IoT webinar. And for that, we have Key coming down, and they sent their own evangelist, Chris. And before that, just to let you guys know, if you guys are interested in any other webinars, you guys can register on our community. We do webinars like this on a weekly basis across a bunch of fields and platforms: Java, Xcode, iOS, Android, IoT, a bunch of web development tutorials and webinars, stuff like that. You can register at our community.bemyapp.com. And with that, I'm going to give the mic to Chris from Key and his tag along for IoT building project. So Chris, you have the screen is all yours.
All right, good deal. Can everybody hear me okay and see my screen all right?
Let me see. Actually, we can't see your screen.
You can't see my screen.
If you click on the little green button on the left.
There we go. How about now? We see a PowerPoint slide?
Correct. I see the whole PowerPoint project.
All right, good deal. So thank you for the introduction. My name is Chris Beauchamp, and I'm a mobile engineer at a company called Key. I'm going to do my best throughout to kind of monitor the group chat and the Q&A. We'll get into some code and some demo stuff here in a little bit. But for now, I want to open up with just a few slides as kind of an introduction and a basis for the technical discussion here to come. So first, a little bit about me. Like I said, my name is Chris, and I got started mostly on the app development side. That's my main area of expertise. And I started when the very first iPhone SDK came out. So I was one of the first developers in the App Store, launched a few apps, and really got hooked. Being able to distribute apps to tens of thousands of people from my dorm room in college, I just thought was the coolest thing ever. And that kind of got me the development bug, and I used that to kind of build out a career. And from there, apps are still very important and a big part of what we work on, but IoT is the hot topic these days, right? I mean, devices are getting so popular and so diverse that I threw my hat into that ring as well. So now I'm working on a lot of IoT applications and device level stuff on as well. Over the years, I started an app startup called KeepSafe, and that was probably the most successful app that I've built. And I left that company to kind of continue my own development and working with folks like Key to work on various projects. I didn't want to just stay on one app. I wanted to go and kind of explore the IoT space and kind of learn something new. So that's why I'm here. One other interesting fact about me, the most interesting thing I think I could think of, was that I've snowboarded and surfed in the same day. So way more interesting than any app that I've ever built. I thought that was pretty cool. So that's who I am. And I work for this company called Key. And we have offices worldwide. Our headquarters is actually in Tokyo, Japan. We have an office here in the United States in the San Francisco Bay Area. And we've been around since about 2007 after an MBO from Nokia. and it started as Synclore. We've been doing mobile device backup since 2007. So think like iCloud for iOS. We do something very, very similar for feature phones over in Japan, and have done that for about 10 years now. So we had this sync technology that was used by like carriers and huge corporations. And we wanted to make it a little more developer friendly. So we platformized it and came out with what was called a mobile backend as a service. And you might be familiar with like Parse or StackMob or some of these. Key was very much in the same ring, and still is. So an MBAS provides a layer of tools for developers to easily build an app without worrying about the cloud infrastructure. So we've done that for a number of years, and with IoT, we've expanded to support multiple devices, not just mobile apps, but IoT devices and platforms as well. So we're allowing any developer to leverage our scalable backend to build their own devices and their own services. And that's what we're going to talk about today, how you can actually leverage a tool like Key to build a complete IoT solution. So that's the number one on our agenda. We're just going to talk about a few of the components to building an IoT solution, the things that you need to be aware of, and some of the challenges that you'll face. And the big core of the presentation will definitely be the demo. So I've got some open source code. You can download it and kind of play along, or I highly suggest kind of taking a look after the webinar to see the nitty-gritty details, because we won't be able to cover everything today. It's a big chunk of stuff, but the project is pretty manageable. So hopefully you'll be able to download it and enjoy.
Yeah, after this, the video is going to go directly on YouTube, so you can just download it and watch the video on your own time, on your own schedule.
Even better. So yeah, perfect complement to the code. So you can kind of rewind and see anything that you might have missed or wanted to double check. So I'm going to jump out of the slides real quick because I want to see the group chat, see if there are any questions. Okay, so far so good.
Yeah, we'll do a Q&A at the end once you're done, so that way you can cover everything from A to Z.
We'll dive back in. So a typical IoT solution and the type of stack that we're going to build today generally has three components. At the core, you've got your thing, your actual IoT device. And you've got to have some way for this thing to talk to either the cloud or to talk to other things. So that's the smarts of the solution, right? And then finally, you've got the way that users will interact with your thing. And primarily, we see this is done through mobile apps. So we've got these three big components that we're going to try to solve and build to kind of form this entire IoT solution. Most of the use cases that we tend to see generally fall into these buckets. We've got here on the left where a user is just talking to their app, and the app is talking to the cloud. This is just a mobile app that you've got on your phone. So this is, I mentioned Key started as one of our big functions is an MBAS. This is what the MBAS covers, is just app to cloud. And then you start to interact with things. So think of a Fitbit, a fitness tracker that you have on your wrist. The fitness tracker doesn't talk directly to the cloud because many IoT devices are so battery aware. You try to get as much battery life out of these things as you can. So having a Wi-Fi chip, having a cell chip, that's going to drain your battery a lot faster. So what a lot of devices do is connect through the app or connect through your mobile device through primarily what we see is Bluetooth Low Energy. So the device will send some signals or send some data to the app, and then the app acts as the hub to process the data and then shoot it up to the cloud or other devices that it needs to network with. So this is our second use case, and again, primarily for devices that do not have direct Wi-Fi or cell capability. And the third is where the device does have its own internet connectivity. We see this in a lot of like smart light bulbs, security cameras, where the thing will actually connect to the cloud directly. So the thing is communicating with the cloud, it's sending data, it's receiving commands. And then the cloud is kind of the transport layer, which sends data back to the user in the form of the app. And this is all facilitated by the cloud. This is a little bit more confusing over here, but pretty simple when you think about it. You've got multiple things if on an intranet, let's say. So here we've got 3 smart bulbs. If any of you are familiar with like Philips Hue or LiftX, this is a very common setup where the bulbs will connect to a gateway on your local network. And that gateway will then facilitate the connection to the cloud. So there's a few different ways you can set it up. But these are the main use cases that we see working with IoT providers. So of course, building all of this stuff is really hard. You've got to cloud enable your thing, first of all, whether it's directly from the device or if you're leveraging an app to communicate with the cloud, it's got to be done. So if you're a hardware manufacturer, you might not be the best app developer. You might not be the best cloud developer. So while you may be able to do these things, scaling up a backend service, creating a backend service, this is not trivial. And that's kind of what Key is here to help you just cut this out of the equation. Just worry about building your device and building the app, and we'll help you with the transport layer and the backend services. So once you've got all that set up, being able to remotely manage the things. So imagine you've built a smart light bulb and you've got these light bulbs deployed all over the world. You need to be able to manage all those devices, configure them remotely, send firmware updates. This is another thing that you need to think of. And it just adds to the complexity of not only just building this device and building this service, but how do you manage it once you launch it? And scaling beyond there, it's not a trivial problem to solve. And finally, you've always got to be optimizing. If any of you are existing mobile app developers, you know that once you launch the app and it's out in the App Store, you can't just leave it sit there. You've got to understand what your users are up to, and you've got to really optimize your app and make it as great as you can to continue to lead the market. So all of these components, are things that you need to be aware of when you're going to build out a solution. And as I mentioned, Key provides a lot of different components to kind of help you just not worry about the cloud and not worry about the device management and not worry about the deployment and focus on your device and the user experience that you provide. And these are some of the tools that Key offers, everything from user management, allowing users to log in, even the mundane things like changing and resetting passwords, account management, all this kind of thing. It's all handled out of the box. Data management is another big one, where we are essentially a scalable NoSQL backend for your application, where you never have to worry about any of the cloud infrastructure. You just pop in an SDK into either the mobile app or your embedded device, and it communicates directly with Key Cloud. You just deal with native objects on the device itself. Never have to worry about any kind of API calls. It's just as easy as working with an SDK. And here at the bottom, you'll see we've got support for Android, iOS, HTML5, and also embedded Linux, some real-time operating systems. We're adding new Linux-based and kind of embedded platforms all the time. And at the core, we're a set of APIs that you can access directly as well. So even if we don't cover the exact platform that you're looking for, you can still leverage our services by kind of wrapping them yourself, which we've seen a number of companies do. And in terms of operations, as I mentioned, scaling a backend is not trivial. It's something that, even if you're a cloud provider kind of a platform developer yourself, it's not a trivial problem, and it's going to add a lot of time and a lot of money to your project. So even more so for those who aren't super familiar with cloud, this is definitely a great type of service where you don't have to worry about any of the operations any of the scalability, it's all fully managed for you. Okay, so that's my sales pitch for Key. It's a great service. I've been using it for a number of years, and I actually work as an independent developer and do some consulting here with Key. And one of the reasons that I do that is because I'm an avid user of their service. I've used them in every single app that I've ever built because I don't want to have to worry about the back end code. So I'm not just here to sell you on it. I'm a believer. I'm a user myself. So that all being said, we'll get into the demo itself. Head over to this link. It's on my GitHub page, GitHub/CJ Beauchamp, and then Key Smart Light Demo. That's the main repository. If you want to check it out now, feel free to follow along. Like I mentioned earlier, we're going to skip a few steps, and we're not going to kind of write it from the ground up because there's just too much to cover in the time frame that we have. But definitely check out the code and kind of poke along with us. So when the webinar concludes, you can review the video or dive right in yourself and get your own solution running. So this is the link to have. I'll post it again at the end. And of course, you'll be able to see it in the video as well. So you remember our typical IoT solution. We've got our app, we've got our service, and we've got our thing. What we're going to build is a Key Smart Light. So we're going to build a little iOS app that talks to Key's cloud solution that will then transport commands to essentially a Linux program. And we're going to simulate a light bulb in our Linux box. So I'll show you exactly how here in a moment. Our hardware is going to be this simulated light bulb. I could pull out one of my many light bulbs that I have here in my office, but without the video, it's not going to be a very effective demo, so we're going to do it this way. And it's a great way for you to kind of follow along. If you don't have a smart light bulb on hand, you can build it and simulate it here in our Linux box. And I keep saying Linux box, I'm actually on a Mac, but I'm using VirtualBox to run a Linux operating system here on my Mac. And that's what we're going to be using here in the demo. And we use Linux specifically because that's a very common platform for an IoT device. And a lot of smart bulbs, smart cameras, smart anything usually have an embedded Linux type chip on them. So the idea here is that if you build out the solution here in our simulator, you can then build your own light bulb, copy this code directly into the light bulb, and then be good to go. And then, as I mentioned, we're going to have an iOS app that's going to act as a controller. So you can open up your app, go ahead, turn the power on and off, the brightness, the colors, and it's going to send those signals directly to our embedded Linux simulated light bulb. Okay, so now we're going to dive into the code. So buckle up. I hope it all goes as planned, but I've done enough demos to know that's rarely the case. So we'll see how things go. Give me just one quick second to get set up. Okay, so as I mentioned, I'm running this on a VirtualBox VM, and I've got my Linux machine running here. It's very, very simple, standard install, nothing special. The repository that you can check out is this directory that I have here, and there's build instructions in the README, how you can get all of this up and running on your own, just straight out of the box. Nothing super fancy is required. So we're going to pull up a terminal here and start checking out this directory. We've got iOS, we've got Java Bulb, we've got Linux, and we've got scripts. Those are our main directories here. This thing SDK, this is the Key SDK. So this is provided through their GitHub. We've got it in here as a submodule, but the README instructions will show you how to initialize a submodule and make sure that you pull the key SDK into the project. But the stuff that we've actually written is iOS, Java Bulb, Linux, and scripts. So that's kind of what we'll walk through today, these different components. We'll start with the Java Bulb. And we've got a few different directories here. We've got our source code, and we've got a couple of shell scripts. And the shell scripts I've created just to make it a little easier to compile the code and then run the code with the right arguments. So dig into those if you're intrigued. But when I compile and run, I'm just doing that directly through a shell script. Now when we run our Java program, we're going to see our simulated light bulb pop up. And we'll talk about how that all works here in a moment. But for now, I'm going to open a new terminal and get our embedded Linux code running. So I'll change directories into the Linux folder. And we've got a list of files here. We've got a make file, which you can use to actually compile it. If you make any changes, it's just a single source code. It's this example.c. So you can make changes yourself pretty easily. It's not a huge file or overly complex. So you can use make to create our executable. And once we have our executable, we're going to, again, I've got a shell script here. I've got run.sh. So we'll go ahead and run it, and our program has started. So you might be wondering what the heck is going on here. Here's an example of the shell script, and this is the one running the Linux code. All we're doing is firing the executable and passing in some arguments. We're calling this onboard function and sending in a vendor thing ID and a password. So if we open up the example code, this is all, this is the C code that's designed to go into your Linux device, and in our case, it's the light bulb. Our main function here is going to require some arguments, and that's exactly the arguments that we sent in here in the run.sh file. So we'll find our onboard function. And you'll see we need a vendor thing ID, a thing ID, and a password. So our vendor thing ID, this is how we signify the device itself within Key Cloud. And this device itself is going to have a password associated with it. So I won't go too far into the details here because, again, we're trying to limit the time a little bit. But it's worth understanding that each device can be associated with a user. So this makes perfect sense logically. I download the iOS app, I sign up and register an account, and then I associate light bulbs with that account, so only I can control them. And this vendor thing ID and this password, this is how you're able to link up a user with the devices that they own. So conceptually, that's what you need to know about this onboard function. It's just going to register this device with the cloud and associate it with our user. So that's what we're doing here. We're kind of parsing out the parameters and initializing our key thing. So as I mentioned, we're registering this thing with the Key Cloud. We've got some parameters that you'll have to change in the header file. We've got an app ID and an app key. Now these are associated with your key account. So we need to know where to pipe this data, which app to send this data to. So that's why you type in your app ID and your app key, so that it all goes to the proper install. So that's app level. And then the onboarding process will take in the password that we provided and link it up with the user. So you'll see this while function here at the bottom. This is executing as kind of an infinite process, right? So you would imagine this running on the light bulb itself. You just start it up when the light bulb powers on, and you let it run. And the reason that we let it run here, it's not just the onboarding process that only needs to happen once, but we want this program to continue running to be able to send the light bulb's current state to the cloud and also receive commands from the cloud. So the light bulb needs to be always on, always kind of waiting for new signals to come in. So that's why we've got this set up as a infinite while loop. And you'll notice in our, as we're running the Linux program here, it's going to send in some print lines every now and again, but generally it's just always on and kind of just passively waiting. Now what it's waiting for are any commands coming in from the cloud. So we need to go up to we've got a function up here called action handler. If I can find it, okay. So here's our action handler. This is where we parse in the messages that are coming in from the server. And the transport layer that we're using here for this particular demo is MQTT. It's a very lightweight transport layer to communicate from the cloud to the device. So MQTT packets are sent back and forth as messages, and we parse in the messages here directly on the device to understand the command that we received and then do something with it. So the commands that we'll be receiving here in the light bulb are power states, whether we want to turn the device on and off, what color we want to make the light, and the brightness that we want to make the light. So you'll see here, if we notice that the message is turn power, we're going to go ahead and set some fields here in the memory. So we store the commands and we store the state in memory. And we're actually also going to store it in a file as well to make things a little more clear and also allow our Java program to leverage the current state. So we go through and we can parse out the fields here. And then at the end, we've got this PRV set smart light info. Now what this is doing is it's parsed the command. It understands I want to turn the power on or off. Now it's sending this information to the cloud. So it's syncing the device state between the device itself and the cloud. So we say, okay, the device knows the power needs to be off. We're going to change that in the cloud to say our power is off. So we just want to kind of replicate the data between the device itself and the cloud. So that's all we're doing here in this set smart light info. And we're also calling this write state method. And as I mentioned before, we're not just saving this in memory. We're going to save this to a JSON file, actually, as it turns out. We'll find this. So we're just saving the current state of the device to a JSON file. You can see here we are saving the brightness, the color in RGB mode, and the power as well. So we're open, write, close. Now I mentioned that we leverage this from the Java side. Obviously we've got our bulb already running. If we open up the Java code, which is in the Java bulb directory and the source subdirectory, and then lightbulb controller.java. It's the only Java file in there, should be pretty easy to find. You can see exactly how we're simulating this device. So every second, we've got a timer running, and it's a very simple kind of no-brainer way to do it because I'm not a Java expert. I just wanted to hack something together for this demo. But every second, we're going to check for any changes in the file. So we're monitoring that JSON file that was written within our Linux code, our C code here. And when any changes are detected, we want to update the UI of our Java file or of our Java program. So you can see we're parsing out the JSON, getting the power, the color, and the brightness, and then writing this out to the UI. So anytime that JSON file changes, this UI is going to update. The JSON file is changed from signals that are received from key saying we need to turn on the device, change the brightness, change the color, etc. So this is a lot to follow. I understand. I'm hoping that I'm not completely losing everybody, but we're gonna continue on here, and hopefully things will start to make a little more sense once we start to see signals actually get sent back and forth. Let me take a quick breather here and grab a drink of water. Okay. So we've taken a look at some of the C code, some of the Java code. I want to point you to our scripts section now. So if you're in our directory, you're in our main directory, just pop open this scripts directory. And within there, there's a couple that I want to show. The first is setup, and we're actually going to go ahead and run these now. So we're going to enter the scripts directory. And we want to basically lay the groundwork for the next scripts that we're going to run. So we're just going to kind of set some variables. We're going to export an app ID, an app key, and an app host. Now these, if you're following along, you can use the ones that are embedded. This is all the app IDs and app keys that you'll see for key are for my demo app. If you want to make it your own and go in and be able to authenticate with the Key developer portal and all that, head over to key.com. You can get signed up for free, no credit card, no nothing. And you can provision your own app ID and app key so you can start sending data back and forth to your own app instance. But for demo's sake, you can just kind of follow along here and be sending things to our demo instance that we've got set up. So to run these scripts, we're going to start by doing source setup.sh. And we do source instead of just sh because we want these exported variables to maintain state when we run future commands. We're also going to run source owner.sh. This is going to run through a bunch of curl scripts. If we open owner.sh, you can see there's a few post scripts that we're calling and sending information back and forth to key. And you'll notice I've got an error here. That's because I ran it incorrectly. We actually need to add a username and a password. So our username is Chris, and our password is my favorite password in the world. Don't try it on my Google account, but it's just password. And our thing password as well. So if you remember when we onboarded the device in our example.c code, we onboarded this thing1. And thing1 is associated with my account, my Chris user account. So I'm going to run this script here. And this is going to set an access token and a user ID from KeyCloud so we can make authenticated requests to KeyCloud. So I might not have mentioned, I should take one step back here and tell you why we're running these scripts. So what we're doing through these shell scripts is we want to be able to send signals to the device through the cloud. And before we go in and do this within the iOS app, we're just going to use these shell scripts to simply kind of show how these mechanics work. And the shell scripts are just going to be kind of a foundation for what we do later in the iOS app itself. But it's a great way to kind of test out your C code. It's a great way to test out the communication between the cloud and the C code is through these scripts. So it just kind of minimizes the things that you would need to debug, because if you got your iOS app already up and running, that's just one added layer of complexity. So I really like to use shell scripts like this to kind of hack things together and make sure things are working properly. So now that we've got the shell scripts set up, we've got an access token in place so we can authenticate requests. We're going to call this smart light command post. And we'll go ahead and call that as just a normal shell script. You'll notice something happened there, right? Our light bulb actually changed color. So finally, you can stop listening to me talk and you can actually see something happening. What exactly happened there is we sent this request to the key backend. And we made a request to that thing that we specified, thing one. And we sent to it a command. So we hit the commands endpoint, and we sent this JSON payload to the device. So what's happening here, we're sending the command to key cloud. Key cloud is then sending an MQTT message to our C code. And remember our C code was sitting there churning, just waiting for an MQTT message to come in. So it got this message, and it parsed out the power needs to be on. The brightness should be at 100, and this is the color that we want to change the light to. And that's exactly what happened here, here in the bulb itself. So we've got a brightness at 100, and we've got 0 red, 255 green, 255 blue. And all of these numbers that we set are on a scale from 0 to 255. So let's say we want to kick up the brightness and make it a really rich blue. We can change the brightness here in this script. Run the script once more. And our bulb has changed to kind of a brighter blue. We'll do one more here to really drill this home. But this is a great starting point for you to kind of see this in action, start fiddling around with the scripts and start seeing how the different changes in your code will affect the light bulb itself and how it communicates with key. So we'll post this once more, and it should just be going to like a really pure blue here with the parameters that we set. And there we go. So we've successfully kind of got the device itself hooked into the cloud, and we're able to send commands back and forth from the cloud itself. Okay, so the next step I want to show is the web console that we have at Key. So if you don't want to deal with all these curl scripts, you want to go directly through the portal, you can do that. Here I've got my demo app set up. As I mentioned before, you can come in here and provision your own app, turn in your own API, app ID, app key, and they'll start to point the data directly to your app that you've got provisioned. You'll see a number of different tabs here. We can add different users to our application. Here's my user, the username Chris, password. And you can store some data as well. If you want to learn more about our data storage, you should check out the documentation. I'm not going to get into this side of things. I'm going to focus on the IoT side itself, where we're sending commands back and forth. But it's worth understanding that, hey, we also have full JSON kind of document style data storage. So we're going to dive right into the ThingIF console. And you'll notice that this is in our lab section. It's because the ThingIF, IF stands for Interaction Framework, is kind of a new layer that we've built on top of our platform. And this interaction framework is what allows us to send commands back and forth. So we've got our main kind of data infrastructure here, user infrastructure. We built a small, thin layer on top of that because we see so many developers kind of leveraging the same tools and rebuilding the same things over and over again to just be able to send commands back and forth from cloud to device. So we created that layer already for you. And that's in the form of this thing IF. So here we've got our thing1 that we provisioned earlier in the C code. And this is our device. This is a cloud representation of the device that we've created. And this light bulb in particular. So we've got a few different things here. You can add all kinds of different metadata, different string number fields, and even some custom attributes in the form of JSON. What we want to look at that's relevant to the demo is this state and then commands. So as I mentioned in the C code, we wanted to always be synchronizing the state between the device itself and the cloud. Well, when we make that call in the C code, it's just sending up the state in this form. So this is read only here in the dev portal, but it gives you an idea of, okay, what's exactly happening on the device right now. We've got our brightness at 255, our bright blue color, and the power is on. So if we go back in and let's say change the color to just green, we're going to run our post command once more. And you see the light bulb turn green. And if you go back in here into the key console and refresh the data, head back into our state, you can see the color has changed to our 255 in green. So again, this state is just being synced between the device and the cloud. Oh, we've also got this commands console. You can see all the different commands that have been run, that have been sent to Key Cloud in the form of an API request and then transmitted onto the device. So you'll see we've got our last command here. We sent that green color from our post script here. So you can see that command, that exact command that we sent here in the console. So this is a great way to kind of track and debug any issues that you might be having because you can see the commands as they're coming in. And it's all, of course, in real time. Just hit refresh and you can see all the latest commands. What we're going to do is grab one of these out of here. So we're going to grab the color and we're going to create a new command. So we're going to add this action to our console here. We need to authenticate ourselves, and we can simulate that authentication here in the portal. So we're going to grab our Chris user, and this is now going to send the command from the portal authenticated as Chris. So imagine a use case where you send a command from, let's say, Peter. Peter's not authenticated to access this thing. So that command, in that case, would fail, highlighting kind of, okay, I own this device, so I'm the only one that can send commands to it. We need to specify a schema and a version. And let me remember what our schema was. Smart Light Demo. And you can define a schema based on the commands that you want to be able to receive. This allows you to be very granular with, okay, we only want to see color, power, and brightness. So if any other message comes in, our schema can block it out, kind of reducing the noise on the device and reducing the noise in the cloud. So setting a schema is a nice way to make sure the data coming in is exactly what you want it to be. Now we're going to go ahead and send this command. And I am a terrible demoer because I should have changed the color there. We're going to replicate this here because I screwed up. And we're going to change the color. So we'll make it, we'll go back to red. and Chris, our schema. Okay, so now we're going to keep an eye on the light bulb as I run this command. If I can arrange my windows appropriately. There we go. Okay, so the light bulb should hopefully turn red. There it goes. So we're doing the same thing through the web portal that we did via this shell script, and just sending a command through key cloud down into the device. So it's a great way, again, if you don't want to muck around with the shell scripts, you can go directly into the portal and start sending commands. And our updated state shows that the color is now red. So everything's working as expected. I'm pretty happy with the way things are going because nothing has failed horribly. So we'll see if we can't start breaking stuff for real here and jump into iOS. Because we want to complete the user experience. It's one thing to be able to test with these scripts and through the portal, but we want to actually have a functioning app. And that's exactly what we've got in our iOS directory within our GitHub repository. So let me pull up the app. I've got this actually screening from my device itself, and I'll tell you why here in a moment. But our device, when it boots up the app, it's going to pull the current state down from the cloud and then visually represent it here on the iOS device. Now, if I do something like add blue and slide up our blue slider, it'll send, there we go. I got to break something. So you'll notice that the light bulb did in fact update, which is good. What happened when we changed the slider here was it created a command, sent that command to key sent the command down to the device. But what we've done is also exposed a bug in my program, which is good, but not catastrophic. So we'll pull up the code and show you exactly what's happening here in the iOS side of things. Let me grab my Xcode here. Arrange our window. So again, this is going to be a very simple app. If you've ever done Swift, if you've ever done iOS, it's going to be very, very easy to follow along. If you haven't done either of those, still might be pretty easy to follow along. We've got just a single app delegate and view controller. Our app delegate is going to initiate our key instance and again tie it in with our app ID and app key. And it's also going to register for remote notifications. So if you're familiar, at least as a user, you understand when push notifications come in, you're prompted to do something. Well, we're signing up for that here in the app and registering for push notifications, but we're going to use them in a different way, and I'll show you exactly how. The callback method, anytime a notification is received within the iOS app, it's going to call this method, and it's going to post a notification to the rest of our app called device updated. So we're going to go into our view controller and register to listen for this particular notification. When any of these notifications come in, we're going to make this method call called getStates. Now this getStates call extracts the current state from the key cloud. So anytime the iOS app gets a notification, it's going to get the current state of the light bulb as key cloud understands it to be. So that's kind of the receiving end of the iOS app. But what happens when you, let's say, change the slider? Oops, I got to do it on the device itself. So let's say we change the green. And go ahead, it's going to turn into some kind of yellowish color. There we go, and it worked properly that time. When the values are changed, it's going to send a command to key cloud. So if you'll see power, brightness, color, and then it's just extracting the colors from the slider and sending it as a command. So we're posting this command to key cloud. Again, we're using the schema that we've already predefined, smart light demo, and the proper schema number. And once this command is sent, we don't really need to do anything on the app, because on the iOS side, we don't really care. But when this command is posted, it's doing the same thing that we did in the portal, and it's doing the same thing that we did within the shell scripts. It's just posting this JSON command through our SDK. So that's why anytime these sliders are updated, oops, say to a green, that's why the bulb is changing, because it's sending that command directly through key cloud. Now I have a hunch as to why that bug was happening. And I think I can demonstrate here. It looks like we've got about 10 minutes left, but I'll be quick. So we're going to go back into our portal and we're going to send a new command. And we're just going to change the color, as we've done a couple of times here. And we'll change it back to a bright red. Okay, so what we're going to do here, we're going to send this command from the cloud, which is kind of a third-party source, or send it from the portal, rather, would be a better word for it. What we want to happen is see our actual bulb change color, and then see our iOS app change color. So we're going to send the command. We see our bulb turn red. And hopefully, there we go, the iOS app turned red. So this is a perfect, I'm so glad that worked out. Because what's happening here is the portal is sending a command to the device. The device ingests the command and says, okay, I'm going to change my color to red. And then the device updates its state on the cloud. So the device will then send its state back up to the cloud. The cloud will initiate a notification down to the apps that have registered. So in our case, the iOS app. So anytime the light bulb itself changes state, it doesn't matter where the command came from or why the state changed. Anytime that light bulb changes state, the iOS app is going to receive a notification. And as I showed here in the code, when the notification is parsed, we get the notification here in the delegate. The notification is parsed, and we say, okay, we want to retrieve the latest state because the notification of state change came in. So we're going to go and access the cloud and get the latest state and then update the UI. So that's exactly what happened here. The iOS app got a notification that the state changed, then it retrieved the latest state down from the cloud and updated the UI. So that's full circle. We've got an iOS app that can control a simulated light bulb, and the light bulb can be controlled from various sources. You imagine different family members might have the app on their phone, and they're all kind of changing the color of the light from different sources. It doesn't matter. All the commands are getting filtered through the cloud and sent directly to the device itself. And any state changes are then propagated on each of your family's devices via the iOS app. So they're always kind of synchronized and showing the current state of the light bulb. Okay. So in a mad sprint, we've been able to get done. I think I'm out of slides. Yes, I am. So once again, the GitHub repository has all of this code. It's got essentially 4 separate projects, and it's got iOS, it's got the Linux side, a Java emulator, and then some scripts as well to kind of get you rolling. As I mentioned, this is all able to be done right out of the box. I highly suggest signing up for KeyCloud and getting your own app ID and app key, plugging them into the code where appropriate, and being able to control your own simulated device through your own key developer portal. And it's very cool and fun to get all this working because you can see the entire user interaction from the app side all the way down to the hardware side. So this demo, and not a lot of code, you can create your own IoT solution, hopefully transport it over to your own device, and get your product out there in a much faster time frame than if you were to build your own cloud, your own interactions between devices. Just leave all that to the key side and focus on the app itself and the device itself. So with that, I'm really tired of hearing myself talk. So I'll flip it over back to you, and I'll also take a look to see if we've got any questions that have been added.
It looks like you did an amazing job explaining it because we haven't had any questions. It looks like everyone clearly understood it and followed through.
Either that or I sufficiently confused everybody at square one and they were just terrified to ask any questions. But I want to leave my email up here. If you do have any questions and are just a little too timid to say, or you still want to dig into things a little bit, I've got my email address here, chris.beauchamp@key.com, or you can grab us on Twitter at KeyCorp, where we'll be able to answer any questions that you have there. I just want to throw that out there, not to interrupt.
No, sounds good. Like I said, folks, we're going to be uploading this video straight to YouTube. So the same link that you used to click on this live stream, it's going to be used as the same link. So if you want to come back and you want to experiment, if you missed a part, if you want to go back and slow it down, you have that at your disposal. I want to say again a big thanks to Chris and Keith for helping us out on this part. I really appreciate it. Chris is actually based in Cali, so it's pretty early for him. So again, thanks for waking up on time. And with that, without further ado, I want to say thanks everyone for tuning in. We're going to be emailing everyone out the YouTube link, as well as Chris's email and Twitter tag if anybody has any questions. Chris, any final words?
I don't. Thanks so much for having me. I always love talking about apps and talking about IoT. So this was a treat for me, and I really hope that y'all check out the project and follow up with any questions that you have. But thanks for joining, and thanks for allowing me to come in and speak.
Sounds good. All right, ladies and gentlemen, that'll be the end of this. And until next time. Oh wait, I'm sorry. Cool. We have actually from Martin. He just says he just want to say thanks.
Oh, my pleasure. Yeah, good to hear from you.
All right, ladies and gentlemen, have a good night or have a good evening, depending on where in the world you are. Cheers.
All right, goodbye, everybody.